Calculus examples. The quotient rule. This is video 11. Example 2 uses the quotient rule in the form given in video 9b. See below. The following list of 5 short videos shows all videos, including this one, that involve the quotient rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. An example using the quotient rule. Find the derivative of the function y equals 4x squared minus 9 divided by x into x minus 7. Solution. Finding the derivative. Method 1. A step-by-step method. Step 1. Identify f(x) and g(x) on the right-hand side of the function you want to differentiate. Comparing the right-hand side of the equation y equals 4x squared minus 9 divided by x into x minus 7 with the right-hand side of the equation y equals f(x) divided by gx gives f(x) equals 4x squared minus 9 and gx equals x into x minus 7. So after expanding, gx equals x squared because x times x is x squared minus 7x because x times minus 7 is minus 7x. Step 2. Substitute f(x) and gx into the right-hand side of the quotient rule. The quotient rule, which is formula B in video 9 on the first screen of this video, is as follows. So for this example, y-x equals gx is x squared minus 7x because gx equals x squared minus 7x times d dx of f(x) is d dx of 4x squared minus 9 because f(x) equals 4x squared minus 9 minus f(x) is 4x squared minus 9 because f(x) equals 4x squared minus 9 times d dx of gx is d dx of x squared minus 7x because gx equals x squared minus 7x divided by gx all squared is x into x minus 7 all squared because gx equals x into x minus 7. Call this equation equation 1. Note that it is better to use the factored form of gx in the denominator, i.e. x into x minus 7. See reminder 1. To review steps 1 and 2, you should pause this video now. Step 3. Evaluate d dx of fx and d dx of gx. Then substitute them into equation 1 in step 2, which is displayed below. So for this example, y dash x equals, bring down x squared minus 7x times d dx of 4x squared is 8x minus d dx of 9 is 0 minus bring down 4x squared minus 9 times d dx of x squared is 2x minus d dx of 7x is 7 divided by x into x minus 7 all squared. Therefore, y dash x equals, bring down x squared minus 7x times bring down 8x minus bring down 4x squared minus 9 times bring down 2x minus 7 divided by x into x minus 7 all squared. Call this equation equation 2. To review step 3, you should pause this video now. Finding the derivative. Method 2. A direct method. Like method 1, method 2 finds the derivative of a function using the quotient rule. However, in method 2, the terms in the quotient rule formula are identified directly from the function in the question and then substituted directly into the quotient rule formula. The function in the question is after expanding the denominator. From step 2, the quotient rule is. So for this example, y dash x equals gx is x squared minus 7x. So substitute x squared minus 7x times d dx of fx is the derivative of 4x squared minus 9, which is 8x, minus fx is 4x squared minus 9. So substitute 4x squared minus 9 times d dx of gx is the derivative of x squared minus 7x, which is 2x minus 7, divided by gx all squared is x into x minus 7 all squared. So substitute x into x minus 7 all squared. Call this equation equation 3. After practicing for a short time, you will find that method 2 is much quicker than method 1, which is why you will probably prefer it. See reminder 2. You should check that writing down equation 3 as the derivative without any working at all is acceptable to your instructor or lecturer. To review method 2 above, you should pause this video now. Simplifying the derivative. Step 4. If the derivative can be simplified, then it should be simplified. From equation 3 on the previous screen, the derivative is the objective is to simplify the numerator while leaving the denominator unchanged. Equals. Move 8x in front of x squared minus 7x. 8x times x squared minus 7x minus bring down 4x squared minus 9 times bring down 2x minus 7 divided by x into x minus 7 all squared equals. Expand the first bracket. 8x times x squared is 8x cubed. 8x times minus 7x is minus 56x squared minus. Expand the last two brackets inside two brackets. See reminder 3. 4x squared times 2x is 8x cubed. 4x squared times minus 7 is minus 28x squared. Minus 9 times 2x is minus 18x. Minus 9 times minus 7 is plus 63. Divided by x into x minus 7 all squared equals. Remove the brackets. Bring down 8x cubed. Bring down minus 56x squared. Minus 8x cubed is minus 8x cubed. Minus 28x squared is plus 28x squared. Minus 18x is plus 18x. Minus plus 63 is minus 63. Divided by x into x minus 7 all squared equals. Cancel 8x cubed with minus 28x cubed. Collect like terms. Minus 56x squared plus 28x squared equals minus 28x squared. So substitute minus 28x squared. Bring plus 18x down plus 18x. Bring minus 63 down minus 63. Divided by x into x minus 7 all squared. Therefore, the derivative of the function y equals 4x squared minus 9 divided by x into x minus 7 is y dash x equals minus 28x squared plus 18x minus 63 divided by x into x minus 7 all squared. While the derivative is correct, it will not match the answer obtained by Maple Math software. This is discussed on the next screen. To review the above working, you should pause this video now. Checking the exponents of x in a polynomial. From the previous screen, the exponents of x in the polynomial in the numerator do descend from left to right, which is correct. To show this, 1. Replace the red exponent in 28x squared with a blue exponent. 2. Insert a blue 1 as an exponent of x in 18x. Since x to the 1 equals x, 18x remains unchanged. 3. Replace 63 with 63x to the naught. Since x to the naught equals 1, 63 remains unchanged. Since the exponents of x in the polynomial are 2, 1, 0, the exponents of x do descend from left to right, changing the sign of the leading term of a polynomial from minus to plus to match the answer obtained by Maple. The sign of the 28x squared term, the leading term in the polynomial, is negative when it should be positive. The following 4 steps explain how to change the minus to a plus without affecting the value of the derivative. Step 1. From the equation at the top of this screen, the derivative is as follows. Now put brackets around the numerator. Step 2. put a minus sign in front of the bracket in the numerator and change the sign of each term inside the bracket. See Reminder 4. Step 3. Rub out the plus before 28x squared. Now tidy up the entire expression. Step 4. Move the green minus sign in front of the bracket in front of the entire expression. Call this equation Equation 4. Equation 4 is the derivative of y. Now the numerator matches the answer obtained by Maple. For the denominator, see Reminder 5. To review the above working, you should pause this video now. When solving questions from your textbook similar to the example in this video, 1. If you intend to use method 1 to find the derivative, you will find it helpful to display the Step 1 and Step 2 screen first, and then the Step 3 screen second, so you can use them as templates to find the derivative. Or 2. If you intend to use method 2 to find the derivative, you will find it helpful to display the method 2 screen, so you can use it as a template to find the derivative. See the note about method 2 in Reminder 2. Most of my students were able to use method 2 before I moved on to the next topic, and with practice you can too. Once you have obtained the derivative using method 1 or method 2, then if the derivative can be simplified, you must simplify it. In this video, Step 4 shows you how to simplify the derivative. So once you have found the derivative, you should have the Step 4 screen displayed, so you can use it as a template when simplifying a derivative. You should then find this topic simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook. Reminders displayed as references without commentary. To review the above reminders, you should pause this video now. To review the above reminders, you should pause this video now.